Okay, let's see here. We are going to do some examples now of the distribution of x bar. And I got several examples, and so instead of writing everything out here, I basically have, we got the weight of a product, has a mean of 13.47 ounces, and a standard deviation of 0.64 ounces. And it wants us to find the following probabilities. So this one would be for a sample of size 30, okay? And it wants to know the probability that the mean of the sample is less than 13.27 ounces. And then here, the sample sizes are changing, okay? And notice we have a less than probability, a greater than, and a between. So this is going to be an example of each one of the three original cases. So let's say we have a sample of size 30, and we want to know the probability that the mean of the sample is less than 13.27 ounces. So that's step one. That's the x bar probability. So step two, we're going to draw a diagram. And so when I draw my diagram, this is actually d of x bar for n equals 30. That's actually what it is. It's not the population anymore. It's the distribution of x bar for the mean of all the samples of size 30. And so the center of this distribution is mu with a little x bar subscript. And it is equal to the mean of the population, so 13.47. And then the standard deviation is equal to the standard deviation of the population divided by the square root of n. So this would be 0.64 divided by square root of 30. Okay. And maybe I can zoom in a little on these as long as I remember to zoom out when I need to. Okay, so now 13.27 would be below here somewhere. And I want to get the area that's below that. So step three is I'm going to calculate the z-score probability. And so it's going to be the, I'm going to use the z-score for, I'm going to calculate the z-score here, and I'm going to use the z-score formula for the distribution of x bar. So for this one, I'm going to convert this 13.27 into its corresponding z-score. So I subtract the mean, 13.47, and then I'm going to divide this by the standard deviation of the distribution of x bar. So that's 0.64 over the square root of 30. So I'm using this square root of n down here. That's the main difference. You cannot forget that. So that is the z-score formula for the distribution of x bar. Okay, so I'm going to take 13.27 minus 13.47, divide this by, and now remember the important thing is you got to have that entire bottom in parentheses. So I have a beginning parentheses, 0.64 divided by the square root of 30, just like that. And then I get negative 1.71. So this is negative 1.71. That's the z-score. So now, step 4 is I write out the corresponding z-score probability. Change my x bar to z, and it's less than this particular z-score, negative 1.71. And so what I've done is I've used the z-score formula for the distribution of x bar to reduce this x bar probability into its corresponding z-score probability. So this is a less than probability. That's the first case where all I got to do is look it up on the table, and the area on the table is my desired probability. So I look up negative 1.71, and it looks like I get 0.0436. And that will be my final answer for this one. Okay. So, and another way you can think of this is 4.36% of all the means that you could draw out of the population, or I should say 4.36% of all the samples you could draw out would have a mean less than 13.27. Okay? So now let's try this one. This is a greater than probability. I want to find the probability that X bar is greater than 13.58. So now I'm going to draw my distribution. Notice my n has changed. It is now 50. So you got to be paying attention to that. So this is mu with the X bar subscript. That'll remain 13.47. My standard deviation will be 0.64 divided by the square root of 50 now. So that actually changes. Make sure it's clear. That's 50. And this is now d of X bar for n equals 50. Okay, and 13.58 is above this somewhere. I'm not sure where it is. It's maybe further out than that. And I'm going to just write this right up here, 13.58. And so I want all this area up here. Okay, so sorry that's hard to read. Maybe I can point to it like this and say 13.58. There we go. That's not too bad. So now I got to calculate the z-score for this using the z-score formula for the distribution of X bar. So 13.58 minus 13.47 divided by 0.64 over the square root of 50. And I'm going to write it down here. I want room for this one over here. So 13.58 minus, let me actually do it here. 13.58 minus 13.47. Okay, and then I'm going to divide the answer. So it's important that here you put the denominator, the entire denominator in parentheses. And then I have the square root of 50 this time. And then I get this for my z-score. 0.46 it says. Let me just double check here. 13.58 minus 13.47, and then 0.64 divided by the square root of 50. There, that's what I came up with before. I'm not sure what I did there. I might not have had that zero. Okay, I get 1.22 here. So my z-score is 1.22. And so that's the calculating the z-score. So now I write out the corresponding z-score probability. Change my X bar to z greater than, and then the z-score for 1.38 or 13.58 is 1.22. And now I calculate that z-score. So I'm going to look up I calculate this z-score probability. So this is actually a greater than probability. That is case 2. And this is where you have to look it up, and then you take the area on the table and you subtract from 1 to get the area above. Because remember, the table always gives you the area below. So 1.22, and I get 0.8888. 0.8888. And this is 1 minus 0.8888, which I'm thinking is like 0.1222. Let me just make sure. I'm glad I checked that out. 0.1112. So this here is 0.1112. And so that is the desired probability. So you could also think of this as, of all the possible samples you could draw out of size 50, little over 11% of those samples will have a mean greater than 13.58. Okay, so now one more here. Now we take out a real large sample of size 150, and I want to find the probability that the, this should actually be X bar. I want to find the probability that the mean of the sample is between 13.5 and 13.45 and 13.5. So we're going to draw our diagram. Okay, this is now D of X bar for n equals 150. So each time you do this, these are different distributions because they're different sample sizes. Okay, so this is 13.47. Standard deviation is 0.64 divided by square root of 150. So 13.45 is down here somewhere. 13.4 or 50 is up here, and this won't be perfect necessarily. But something like this. And so what I need to do is I need to get those two z-scores. Let's see if I can zoom in a little bit. So I need to get these two z-scores. That's why I wanted room here, because I knew I had two z-scores to find. So that will be the first one. So 13.45 minus 13.47. And then I'm going to divide that by 0.64 divided by the square root of 150 now. Make sure that entire denominator is in parentheses. And I get negative 0.38. Okay, and now this one is going to be 13.50 minus 13.47. Divide that by 0.64 over the square root of 150. Okay, and let's put this in. So 13.50 minus 13.47. Divide that by 0.64 divided by the square root of 150. And I get a positive 0.57. Okay. So these are the two z-scores. One is negative, one's positive. So now this is step 3. All of this was step 3. So now I write the corresponding z-score probability for step 4. Okay, so I'm changing this to the z-score negative 1.38 and this one to the z-score 0.57. Okay, and so I get negative 0.38 less than z less than 0.57. And now what I got to do is I got to look up both probabilities. Remember, this is a between probability. That's the third case, where you look up both z-scores, and then you subtract the two areas. So first, 0.57 on the positive side gives me 7157. And then negative 0.38. So negative 0.38 gives me 3520. And so now my final probability is the difference between these. So 0.7157 minus 0.3520, and I get 0.3637. And that is my final probability. Let's see here. And you can also think of that as, of all the possible samples of size 150 that you could take out, a little over 36% of those samples will have a mean that's between those two, 13.45 and 13.50. Okay, so there you go. There's an example of each of the three cases for probability of the distribution of X bar. So if it's an X bar probability, if you want to find the probability that the mean of a sample is less than, greater than, or between a certain amount, you're basically kind of doing the same 5 steps as before. You're using this mu z-score formula, and then you're going to get the probability for each of those. And so in our next set of videos, we're going to talk more about what is this distribution of X bar and some of its significance, especially when you're doing inferential statistics. And this distribution is where you get the idea of sampling error and critical values. All kinds of important things come out of this. This is kind of the bridge between all this probability stuff and then the statistics, the inferential statistics that we're going to be doing. So this is really important stuff, but as far as actually doing the problems, it's not very different than what we did in the previous set of problems. So another thing we're going to learn is, I did this on purpose. If you notice here, this one I said the height of adult males is normally distributed. But here, I just said the weight of a product has a mean and a standard deviation. I didn't tell you that the weight of the product was normally distributed. Okay? But, as it turns out, as long as our sample is sufficiently large, and the rule of thumb we're going to see is 30 or more, as long as the sample is sufficiently large, you can still use the standard normal table, because the distribution of X bar is actually, even if the original population is not normal, it will actually be approximately normal, okay? As long as n is sufficiently large. And the rule of thumb is greater than or equal to 30. So we're going to talk all about that stuff next time here. And then the other thing, this is a normal distribution. This had only 5 adult males. With a normal distribution, it doesn't matter if your sample is above 30 or not. You can do it for smaller samples. But if it's not normally distributed, or you just don't know, you got to have it 30 or more. We will talk more about that, as well as some of the other ideas involved with the distribution of X bar in our next set of videos.